Today we're going to look at sustainable manufacture of electrical machines and their role in the circular economy. And it's interesting to reflect back that in 2018, when we put this programme together, this aspect didn't feature particularly prominently, but due to interest from our industry partners and a growth in research in this field in many other sectors, it's now become central to what we do as a research team.
I'm Dr Jill Miscandlin and I work at the National Manufacturing Institute Scotland, part of the University of Strathclyde. The current life cycle of machines adopts a linear process, such as take, make, waste. So you take materials from the ground, you manufacture products, and then you discard them at the end of life with no concern for the environmental impact. This is problematic in numerous ways, in that you don't reclaim precious materials at the end of life, and you're adding to landfill instead of reusing and recycling components. The way that we're approaching circular economy within the FEMM Hub is that we're looking at an array of solutions, because the circular economy doesn't dictate one singular solution, but gives you an alternative way of approaching problems so that you can design in sustainability from the very first idea, concept of components or products. The circular economy hierarchy is a ranked option of potential solutions that can be implemented to make components and assemblies more sustainable. The solutions at the top of the hierarchy are most favourable, with the ones at the bottom being least favourable. When we talk about most favourable solutions, we mean the solutions that require less material input, they reduce CO2 emissions more, and they generally require less intervention from engineers. When people often talk about sustainability, their first thought is about recycling. And recycling is an important element of the circular economy in general, but as you can see, it's right at the bottom of the hierarchy, right before we go to landfill. So recycling must be used as an appropriate tool at the appropriate time. You'll see that redesign is right at the top of the hierarchy. Now this is a crucial element, because if we don't consider redesign of components, then all the other things further down the hierarchy become near on impossible to implement. The manufacturing element itself is hugely important to the design of the component, as a lot of the CO2 emissions and a lot of the cost of components comes from that manufacturing stage. By thinking differently about how components are designed and used, we can actually select alternative manufacturing routes which can reduce material consumption, reduce CO2 emissions during manufacture, and reduce weight for transportation and also for the in-use phase.
We developed a technology roadmap which is specifically focused on the transition to net zero by 2050 and what that means for electrical machine manufacturing. There's obviously some implications in terms of performance of the products that we have to provide. There's implications on scarce materials, especially rare earth metals that are limited at a global level, and also cost drivers. And we're using the roadmap now as part of a way of starting a discussion on a more multidisciplinary basis on how we actually achieve the transition and what some of the different factors are that go beyond the engineering and technology.
We're looking at both the short-term and the long-term technical challenges of sustainable electrical machines. So for the short-term issues, there are lots of machines that have not been designed with end of life in mind. We need to devise solutions that capture the significant value already deployed within the UK, especially in the wind energy sector. By 2050, it's estimated that to achieve the expected growth of offshore wind, it will require approximately 14.7 million tonnes of steel, 1.54 million tonnes of ductile iron casting, 93,000 tonnes of neodymium and 67,000 tonnes of copper. The only way that this can be achieved is if we make use of the materials already in the UK. The longer term future looks at the redesigning of machines, and that redesign element is hugely critical so that when we get to 2050, we have machines that have been designed for repair, for life extension and for end of life processing. If we don't do something today about the design of these future machines, come 2050 and beyond, we're going to have major issues with processing very large amounts of material that have not been thought of for end of life processing.